3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch the fourth space-based infrared system satellite for the United States Air Force. Good evening and welcome to Cape Canaveral Air Force Station in Florida. I'm Amanda Cooker and I am a structural engineer on ULA's Vulcan Centaur program. I'm here in Mission Control at the Atlas Spaceflight Operations Center. The team is not working any issues at this time and we are planned for a liftoff at 7:48 p.m. Eastern. We have a 40-minute launch window this evening. A few seconds from now, the count will enter a planned 15-minute hold. There are 2 planned holds in our nearly 7-hour launch count. The planned holds give our team additional time to resolve any issues prior to entering the terminal count at T-minus 4 minutes. Later in the show, I'll be joined by Captain Kristen Cooper from the Space and Missile Systems Center's Remote Sensing Directorate at Los Angeles Air Force Base. Earlier this week, we asked our Instagram followers to post photos of past, present, and future military members in their lives, tagging ULA and using the hashtag SBIRS. Shortly before spacecraft separation tonight, we'll present a slideshow of these photo submissions to recognize the capabilities that satellites like SBIRS provide to American troops. Clay Flynn, the 45th Space Wing's weather officer, recently briefed the team on the weather conditions here at Cape Canaveral. The probability of violating launch constraints is 0%. The ground winds are 6 to 10 knots out of the north, and the temperature is 53 degrees Fahrenheit. So, the weather is within the launch commit criteria and looks favorable for tonight's planned T0 of 7:48 p.m. Eastern. Following a nearly 43-minute flight, the Atlas V 411 rocket will deliver the SBIRS GEO-4 satellite to a geosynchronous transfer orbit. Let's take a look at the events we can expect to see in today's flight.
The following profile details the important events of this mission using approximate times.
5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 main engine and 1 solid rocket booster ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 58 seconds. At 1 minute 11 seconds, the vehicle experiences maximum dynamic pressure. Shortly after liftoff, the Atlas V is burning propellant at a rate of 2,750 pounds per second, traveling at over 10,400 miles per hour, and located 63 miles in altitude and 188 miles downrange. At 2 minutes 20 seconds into flight, the single solid rocket booster is jettisoned. 1 minute 43 seconds later, booster engine cutoff occurs. The booster stage is jettisoned 6 seconds later. 10 seconds after booster separation, the first Centaur main engine start takes place. The payload fairing is jettisoned 8 seconds later. The vehicle now weighs just 8% of what it did at liftoff 4.5 minutes earlier. Cutoff of the Centaur main engine occurs nearly 14 minutes after launch. The mission now enters a 10-minute coast phase. At just over 24 minutes, the Centaur main engine is restarted. This burn will last approximately 5 minutes. Following the second Centaur main engine cutoff at 29 minutes 18 seconds, the mission enters a final 13-minute coast phase. At 42.5 minutes, Centaur releases the 4th SBIRS GEO satellite for the United States Air Force, providing early missile warning detection.
ULA is using the Atlas V 411 configuration to launch SBIRS GEO-4. This is the 75th Atlas V launch and the 125th ULA mission. Produced in Decatur, Alabama and Harlingen, Texas, the Atlas V 411 includes a Common Core booster powered by an RD-180 engine, one Aerojet Rocketdyne solid rocket booster, and a Centaur second stage powered by an Aerojet Rocketdyne RL-10C1 engine. The satellite is protected during ascent by a 4-meter diameter payload fairing. On January 11th, the encapsulated payload was transported to the Vertical Integration Facility, or VIF, at Space Launch Complex 41, where it was mated to the Atlas V rocket. This activity completes the stack and is the last major processing milestone before final launch preps begin. The launch countdown begins with moving the rocket from the VIF to the pad. The quarter-mile trip began using 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the Mobile Launch Platform, or MLP, supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the Portable Environmental Control System provides air conditioning to the payload and rocket. Finally, track mobiles provide the power to move the 3.5 million pound convoy. The Atlas V rocket stands 195 feet tall, or about 20 stories, and weighs more than 850,000 pounds fully fueled with its solid rocket booster. The RD-180 main engine and SRB produce more than 1 million pounds of thrust to lift the rocket off the pad and begin its journey to orbit. As I mentioned earlier, the Atlas V is launching the 4th dedicated satellite in the space-based infrared system. SBIRS, one of the nation's highest priority space programs, is designed to provide global, persistent, and taskable infrared surveillance capabilities to meet 21st century demands in missile warning and defense, technical intelligence, and battle space awareness. The system architecture consists of legacy defense support program satellites, hosted SBIRS sensor payloads in a highly elliptical orbit, and dedicated SBIRS geosynchronous Earth orbiting satellites. The satellite constellation is supported by ground infrastructure, which receives, processes, and delivers the infrared information to key decision makers. Lockheed Martin is the prime contractor for the program, with Northrop Grumman serving as the primary payload provider. The SBIRS team is led by the Remote Sensing Systems Directorate at the U.S. Air Force Space and Missile Systems Center and is operated by Air Force Space Command. The artwork on the payload fairing of the rocket features an eagle, which signifies the Remote Sensing Systems Directorate. The globe represents the importance of this satellite, providing missile warning, which is the cornerstone of deterrence to the U.S. and its allies. Adopting the motto from the 3 previous SBIRS launches, Always Vigilant, Flight 4 logo reads, Semper Vigilans, a tribute to the SBIRS heritage. Today's launch is dedicated in memory of Eric Madison. Eric began his career at ULA as an intern in 2009 and as an employee in 2012. He worked as an IT architect and moved into cyber intelligence, his true passion. While completing his Master's of Science in Information System Technology at George Washington University, he worked closely with our Washington operations team, where he forged lasting relationships with our government customers. Eric willingly took on new and challenging assignments and set a high standard in terms of the quality he delivered to our customers. He was recognized as a rising star within the information technology organization at a very young age. His team members miss him every day.
SRB ignition enabled.
Verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Verify red line monitor and event table are in the correct configuration for terminal count.
Verified.
RC, verify solar radiation is acceptable for launch.
Verified.
L-minus 9 minutes.
Launch on time verified.
Roger.
L-minus 8 minutes.
LC switch to ready position. All steps are complete prior to the status check.
We remain in the planned 15-minute built-in hold as we continue to prepare for liftoff. In a few moments, launch conductor Dylan Rice will poll the launch team for the final go to pick up the countdown. 29 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Dylan Rice performs the final polling of the team.
Status check to proceed with terminal count, Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2. LH2.
Go.
Has gas. Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GC cubed.
Go.
COM.
Go.
Timer.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
CMD, you have permission to launch.
Proceeding with the count. Timer. Set count to start at 0044 Zulu for a plan T0 of 0048 Zulu.
Count will start at 0044 Zulu for a plan T0 of 0048 Zulu.
Polling is complete and the launch team has given the go for launch. From T-minus 4 minutes until launch, you will be listening to launch conductor Dylan Rice and his team performing the final steps in the countdown procedure. You will hear the team call out that Atlas LO2 topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed by verification of Centaur tank pressures. A final status check of Atlas, Centaur, and SBIRS GEO-4 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear the voice of Marty Malinowski providing launch vehicle ascent data.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
The countdown clock has resumed and we are go for launch at 7:48 p.m. Eastern.
T-minus 3 minutes.
Securing LO2 top.
Atlas tanks to flight pressure.
2 minutes, 50 seconds.
FTS internal.
One minute, 59.
Vehicle internal.
155.
Launch sequence start.
150.
Securing Centaur LH2. Securing Centaur LH2.
1 minute, 40 seconds.
Launch enabled.
137.
FTS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
OCUs armed.
SCS count started.
115. 110.
Vent valves locked.
T-minus 1 minute.
T-minus 1 minute.
Rock, report range status.
Range green.
T-minus 40 seconds.
Stable at step 3.
28 seconds. 25.
Status check.
Go Atlas.
Go Centaur. Go SBIRS.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition and liftoff of the United Launch Alliance Atlas V rocket carrying the 4th space-based infrared system for the United States Air Force. You are hearing the voice of Marty Malinowski providing launch vehicle ascent data.
throttled down as expected. Mach 1. Boosters throttled back up. Max Q. Coming up on SRB burnout shortly. Performance continues to look good. RD-180 chamber pressures continue to be steady. And we have indication of SRB burnout. Current altitude is 14 miles, downrange distance 11 miles, current velocity 2,622 miles per hour. Booster has throttled down as expected at this point in the mission. And the vehicle is now 50% its liftoff weight. RD-180 continues to perform well. Coming up on SRB jettison. And we have indication of jettison of the SRB. Looks like a clean separation. 2 alpha closed loop steering has begun. Booster has begun roll bias pointing. RCS pyro valve has been firing. That system is now pressurizing to flight levels. Signatures look good. Current altitude is 43 miles, downrange distance 94 miles, current velocity 6,691 miles per hour. Booster has throttled back as expected. Currently the vehicle is 25% its liftoff weight. Coming up on our 5G throttle segment. Boost phase cooldown is underway. Turbo pyro valve has been fired. Now throttling to maintain 4.6 Gs. Boost phase cooldown is complete, and we have MECO. We have stage separation. Oxygen fuel pre-start on the RL-10. GN2 purge firing is underway. We have ignition and full thrust on the RL-10. Yep. And we have payload firing jettison. Indications are a good jettison. RL-10 is burning at set mixture